Hello everyone, we are Group 6 and our proposed topic is solar car, especially Aptiva EV. I am Mohammad Yusuf bin Hashem and below are my group members. Before we start the presentation, I would like to discuss about a bit about our topic content, what we're going to discuss in the presentation. First, we're going to talk about the introduction of PV and EV, the design criteria of the EV, solar car parts and application, power conditioning unit, grid connected or stand-alone of the system, the advantages and disadvantages of the system. This is the introduction to PV and EV. So what is PV? In general, the form meaning is the generation of electricity current when two semiconductors are exposed to light. Here the light we are talking about sunlight. The difference is noted between two semiconductor known as photovoltaic effect. The photon strike the atom and the electron is loosed. So when it is loose, it converts into electricity. The diagram in the slide shows that shows the operation of a basic photovoltaic cell, which is also known as solar cell. Solar cells are made of same kinds of semiconductor materials such as silicon. For solar cell, a thin semiconductor wafer is specially treated to form an electric field, positive on one side and negative on other side. When light strikes the solar cell, electrons are knocked loose from the atoms in the semiconductor material. If electrical conductors are attached to the positive and negative side and the circuit is built up, the electrons can flow or can be captured in the form of electric current. This electricity can be used to power any load. In PV, there is a term known as a solar array. So what is solar array? In simple term, combining several solar panels creates an array. Let's break down solar array furthermore. A solar array starts with a single solar cell or photovoltaic cell, which are then grouped together to make a solar panel or modules. The group of solar panels is known as solar array. Moving forward, we are going to introduce you about electric vehicle. All electric vehicles, also referred to as battery electric vehicles, have an electric motor instead of an internal combustion engine. The vehicle uses a large traction battery pack to power the electric motor and must be plugged into a wall outlet or charging port to charge the vehicle. Because it runs on electricity, the vehicle doesn't emits any kind of greenhouse gas, or it don't need any kind of fuel or need to refuel in any petrol pump. The key components of an electric vehicles are the battery pack. All electric cars have battery pack, have a DC to DC converter, and charging port, electric traction motor, onboard charger, power electronics controller, thermal system for cooling, traction battery pack, and a transmission to convert the electric energy to mechanical energy. Now we are here to talk about solar cars. So we have introduced you about the PV and EV. When PV and EV are combined together, we get a solar car. So solar cars are powered by electricity through use of solar energy. You can say that. So solar panels are attached to surface. Or a roof of the car. The cell converts the sun's energy directly into electrical energy. The energy is then stored in the battery for use. Some solar cars for commercial purpose can also charge through wall plug, just like normal EV. Solar cars have a lot of limitations due to PV and battery limitations. Research is still going on, but it is considered as one of the clean energy powered vehicle, and it is expected that in future all car will be a solar car.
Hello, my name is Mohammad Shafir Nazmi, and I will be presenting about the design criteria of Aptera EV, as it uses solar energy to charge the car and to operate. And this car is designed for the two-seaters, which is the length is about 4.369 meter, the width is 2.235 meter, and the height is 1.448 meter. But the size of it is quite large for the two-seaters. And but this car, because this car is fully equipped with the solar panel, it gets 700 watts of continuous charging power, whether you're driving or you simply park. And the performance of the car is, by using all the wheel, you can get up to 60 miles per hour within 3.5 seconds, or you can use only the front wheel drive, which is you can get the same distance but in much more time taken, which is 5.5 seconds. The top speed of this car is maximum at 110 miles per hour, which is at 177 kilometer per hour. And also if the solar energy is not enough to move around, you can charge the car by using the charger, electric charger, and it has two types, which is one the standard plug, and another one is rapid DC chargers. And the standard plug you can get 30 miles in 1 hour charge, and the rapid DC charger you can get up to 500 miles in 1 hour charge, which is fast. And this car requires less than 100 watt hour of energy per mile, which making it energy efficient as quite efficient of the Tesla Model 3. And this car has four models, which came with 4 different battery size, which is the smallest is at 25 kilowatt hour lithium ion, and the largest is 100 kilowatt hour lithium ion. The smallest we can get up to 250 miles in one charge, and also the largest battery can get up to 100 miles in one charge. The solar features itself is useful as it self-charges itself up to 60 kilometers while simply park and not doing anything. And also by adding solar to the hood and the rear hatch, it can move for 24 miles of addition because of the solar charging per day. Let's move to the solar car parts and application.
Hello and good day everyone. My name is Ibrahim Al Nurdin Hassan and I'm going to present on the solar car parts and applications. So for the first part in the solar car, and it's one of the most important parts in the car, is the solar arrays. And basically the solar arrays are known as solar panels, are made up of thousands of photovoltaic cells that converts the sunlight into energy. And the process of converting the sunlight into energy we know as when the solar arrays, which is the photons, hit on the PV cells, and then it combined with the atoms in the semiconductor materials used for the PV cells, and then we're going to have the electron pairs, electron hole pairs, and then the electron move in the opposite direction, and thus we're going to have the energy converted into electrical energy that goes to the battery. And we know that the solar panels are placed on top of the car because that's the point where the sunlight hits the car first. So all the solar panels are placed on top of the cars. And there are many materials that are made from the solar panels, which is like we can have a silicon or mixed alloy of gallium and indium as well. Also nitrogen gas. It makes up the photovoltaic cells in the solar panel. And we have other components such as the power trackers. The power trackers basically assist in directing the solar energy generated to the battery for storage, and they also serve as a stopper to prevent the overcharging of the batteries. Moreover, the power trackers convert the solar array voltage to the system voltage, and in this step, the array changes the energy that it's received to an energy that the car can use. The another component is the battery, and the battery basically takes the energy necessary to power the motors and controller. All are stored in the battery. So after the process of converting the solar arrays into electrical energy, it is all stored in the battery, and then the battery will charge the motor and all other components in the car. A standard solar car battery pack is adequate to allow the vehicle to drive around 250 miles, which is around 400 kilometers, without the use of the sun and maintain speeds of 600 miles per hour. And the batteries store energy from the power tracker and makes them available for the motor use. And after the tracker converts the energy to energy that is usable for the car, it sends it to the battery, and then the battery stores the energy. And the energy is sent to the motor and controller to make the car run. The electric motor is another component in the car, and it converts the electrical energy into mechanical energy by moving the wheel movements in the car. And the motor controller adjusts the amount of the energy that flows to the motor that corresponds to the throttle. And the motor uses that energy to drive the wheels. And lastly, we have the speed controller. The speed controller assists in monitoring the vehicle's speed and controlling the engine and wheels accordingly.
Hello, this is Asil, and we're presenting about subtopic grid connected or standalone. So, the system that is connected to the solar vehicle is standalone. So basically, when talking about standalone, it means that the system is basically independent from the utility and use battery to compensate uh, the load when the PV doesn't meet the required load. So we use the battery to compensate that problem. So the system components here are the PV panel, which is the main source of energy, the MPPT, post converter, ESS batteries, two DC-DC charging converters, which is the first quadrant and the two quadrant, AV charger and AV battery. Okay, so here we have the PV panel represent the main source of energy for supplying the solar car. However, the generated energy is not steady. It varies according to the solar to the isolation level of the environment issues. Therefore, we use the ESS batteries uh, that are usually used to compensate for the problem of energy intermittence. So the output terminal of the PV are connected to the post converter here. Its function is to match the PV voltage level to that of DC bus and helps utilize the maximum power point tracking. Two charging converters are connected to DC bus, namely the EV charger and the energy storage converter. These converters are generally DC-DC converters. However, the AV charger is one quadrant back converter that is used to charge the AV battery, which is the lithium-ion battery. It serves in regulating the charging process of the battery of the electrical vehicle battery, as shown here. However, the energy storage converter is two quadrant. This part. Uh, it is used to control the charge and discharge process of the storage battery, which is the lead acid. In addition, it participates in regulating the bus voltage against the variation of the electrical vehicle load and isolation level.
Assalamu alaikum. My name is Abdullah. and I'm going to explain the power conditioning unit, or the PCU. So the solar power conditioning unit, or the SPCU, is a fully integrated system that allows the battery bank to be charged using either solar or grid power. The following are the components of a solar power conditioning unit, starting with a charger for the solar, an inverter, a charger for the grid, the mechanism of the output selector, and lastly the mechanism of the battery. The solar array voltage is converted to a system voltage by the PCU. The stage involves the car's PCU receiving energy from the solar array and converting the energy into energy that the automobile can utilize. It transforms energy and feeds it to the battery. The battery stores the PCU energy and make it available to the motor. After the PCU transforms the energy to a form that can be used by the automobile. It transfers it to the battery, which the battery stores the energy. The motor and the controller receives the energy. Lastly, motor and controller to corresponded to the throttle. The motor control changes the amount of energy flowing to the motor. The energy is used by the engine to propel the wheels forward. The motor changes the amount of energy that goes to the throttle when energy is supplied from the battery to the motor. The energy received by the motor is used to drive the wheels. This is how the solar automobile functions.
Hi, my name is Muhammad Haziq bin Jamari. So I will explain about impact to society, advantages and disadvantages of solar car. So for social impact of electric cars, simply said, electric cars make our cities safer for pedestrians and cyclists. One electric vehicle on the road for a year may save 1.5 million grams of CO2. That's the equivalent of 4 return flights from London to Barcelona. So next we go to the benefits and drawbacks of solar energy car. So for the benefits, first, no more gas to the environment. The solar energy car can be operated without emitting any gases into the atmosphere. The electric motor generates electricity that doesn't emit any greenhouse gases or any other pollutants. These cars are quieter than the vehicles powered by conventional fuels, which don't cause noise pollution as well. Next, natural resources saving. During production, solar power tends to consume resources and energy, but there is no extra energy or inputs required to operate once the production is done. Therefore, once we shift to using solar-powered vehicles, we can save many resources, as such cars do not need fuel, gas, or maintenance resources. Next, no energy cost. Solar-powered vehicles come with the solar panels that allow us free sunlight to charge, and once user's car is fully charged, user will drive off without spending $1 on fuel. Since solar energy is free and renewable, user will find they're saving a lot of money when they drive one of these cars. Last but not least, technology of future. Ever since the first solar-powered car was invented, investors have realized that solar energy is the way to go. All they need to do is develop a sophisticated technology that will use solar energy to operate. Technology is developing every day, and someday we will be able to drive solar-powered vehicles commercially. Next, we go to the drawbacks of solar energy car. First, high initial cost. Everything is expensive when it comes to solar. For example, the efficient solar panels and batteries and their replacement are way too expensive that need to be changed so often. Next, weather dependent. Solar-powered vehicles need direct sunlight, and when sunlight is not available, there will be a slight problem. The batteries are only charged during the day when there is sufficient sunlight. The energy can be used at night, and if users did not store sufficient energy, they might be in a serious problem. Next, energy storage capacity. The number one reason why solar-powered vehicles can move is that they use energy. That energy needs to be stored in solar batteries, which might be hard when there is no sun for some days. The batteries are only charged during the day when there is sufficient sunlight. The energy can be used at night, and if users did not store sufficient energy, they might be in a serious problem. Last but not least, manufacturing causes pollution. During the manufacturing process, there are harmful materials that are always used, causing harm to the atmosphere. Transporting those parts to and from the factory will pollute the ozone layer, but we can never compare the amount of pollution caused by solar production to fuel-powered cars. So, in a nutshell, we saw how Aptera electric vehicles speeds to 60 km/h in 3.5 seconds. Poor weather conditions, driving conditions, improper positionings of the panels, and accumulations of dirt would likely make solar cars struggle to reach this figure. Plus, solar-powered cars are not 100% eco-friendly. If you look at the way batteries and solar cells are made, especially how the minerals used are mined from the earth, it becomes clear that each vehicle comes with its share of carbon footprint. But that doesn't mean that they will not become widespread in the coming years. Current research into low-weight batteries and high-efficiency photovoltaic cells may one day make solar-powered cars viable. So, with that, I thank you.